Hey everyone, my name is Zach Brady, and I'm a field engineer here at Rancher Government Solutions, also known as Rancher Federal, and today we are going to be running through an effortless deployment of the Rancher stack. Now the Rancher ecosystem consists of many products, many technologies. It's a vast system, but today we're going to be running through what I consider, and what most consider, our 4 core products. And those products consist of RKE2, which is our Kubernetes distribution for the enterprise data centers, Rancher Multi-Cluster Manager, which is our management layer for any Kubernetes distribution, Longhorn, which is for storage, any kind of stateful persistent storage, and then NeuVector, our security tool, which is pretty powerful. Additionally, there will be links to each of these products in the description, also inside of this repository, for you to read more and find out more information about them. But for this specific guide, let's get into it. We're going to be starting with 3 virtual machines. Now these are bare virtual machines. I spun them up on our hyperconverged product known as Harvester. And then we also need the ability to access these virtual machines. So I'm using Terminus, one of my favorite terminal utilities, but you're more than welcome to use whichever one you so please. In this tutorial, in this guide, everything we need is going to be copy-paste right from code blocks, as you can see here. Also, at the top of each code block, you'll see it will tell you which server to run each of these code blocks on. So for this one, this is installing packages and dependencies on each of the servers, each of the nodes, and you can see it tells us there right there. Now, if we scroll down a bit, you'll see one of our next steps, it only tells us to run it on a single node. So for all these guides, feel free to look at the top of each code block to verify before you paste it into each node. But for time-saving purposes, I've also completed this first command here, which is installing a few packages and dependencies. Now this takes maybe 3 to 4 minutes, depending on your internet connection. So I want to get that out of the way before we got started. So the first aspect of this guide is going to be installing RKE2, which is our Kubernetes distribution. And part of that is setting a configuration file. Now you're able to install RKE2 without any configuration changes, but for this guide, I am adding a preset token. And this token allows the worker nodes to register with the control nodes. And RKE2 will normally generate this as a randomly generated token, but for ease, I like to set a secure password. Now obviously this password is not secure, but for this guide, we're going to be using this. So to start off, you can see if I go over to my terminal utility, all of my packages have been installed. I've also yum upgraded as well. So you can see on each of our nodes, all of this has already been completed. So the first step we're going to go ahead and do is copy our configuration file into the first node. And again, all this is doing is setting that token value, which you can see right here. The second command is going to be grabbing the RKE2 installation script and additionally enabling and starting the RKE2 server service. Now the server and control plane, those are interchangeable terms here. You're going to hear server or control plane, means the same thing. Additionally, you're going to hear worker versus agent, and those are the same names as well. Different terminologies, but they're synonyms for each other. Now additionally in this script, you might have seen how we specified a version. So we're going to be installing Kubernetes version 1.24, 1.24, additionally RKE2 1.24. And the reason for that is RKE2 is the only Kubernetes distribution outside of upstream Kubernetes that has a DISA certified stake. And right now we are in the process of getting 1.25 approved, but we are going to stick with 1.24 until that happens. Now this will take maybe another 2 or 3 minutes to run that install script, get any additional dependencies, and then also start and enable the service. So you can see here, I lay out a few extra commands. So if we do finish this and our RKE2 server is not up and running, one way we're able to check that was the systemctl status command. There is also a journalctl command we can run. But for the most part, we should see all of these packages installing, and then right now you can see RKE2 is starting. Now once that starts, this next set of commands here is going to symlink the kubectl binary and the containerd. And this gives us the ability to access kubectl on this local node And additionally, we're also going to be setting where our kube config is and then the path of some local binaries. So if I copy this command here and head back over to this node, we should be up and running in a few seconds here. And then once that's done, you can see that we're able to run a kubectl get nodes, and that is telling us which nodes are available and giving us information about specific nodes. Now, because we've only configured one node, you can see it's only going to be showing us a single node, and that's going to be RKE2 CP01. And if we go back here, you can see that's the exact server I copy and pasted that command onto. And it should look like this. Now, it takes about 40 to 50 seconds for the node to become ready. But what I'm going to do is I'm going to type a watch kubectl get nodes. So as we're starting to work on the worker or agent nodes, we can check back to here to see when they join the cluster. So moving on to the worker node and the second worker node, you can see same kind of configuration file, except we've also added an option known as server. And this is telling the worker nodes the location of our control plane and then also passing that same password that we set originally. And if we go back quickly, you guys can see that we're also in a ready status. So I'm going to paste this command on each of the worker nodes. And then I'm also going to copy and paste the installation script and the enabling and starting of the RKE2 agent service. Now this is the worker nodes or agent. Those terms, remember, are interchangeable. But you can see here it's same kind of methodology, same process for the control plane and worker node. And that's it. Once these two scripts finish installing, we have a 3-node Kubernetes cluster. It's that easy. So while we wait for this to come up, we're going to scroll down a little bit and kind of look to see what the end product's going to look like. You can see we have a control plane node, and we also have 2 worker nodes. Now this is running Kubernetes 1.24 as we talk about. Kubernetes has advanced up a lot further than that, but for our customers, for the government, we see a lot of them adhering to DISA-STIGs and a lot of those security requirements that you see. Heading back to the terminal here, we should be able to see that both of our nodes have come online. If we check each of those, we can see we've successfully started the RKE2 agent service on both of them. And also, as we saw a second ago, we see both the nodes are in the ready status and inside of our cluster. So I'm going to go ahead and quit this watch, and I'm also going to close out those 2 worker nodes because we really do not need those nodes, access to those nodes via SSH any longer. We're going to be doing everything here on that first node. Again, this is where we have kubectl. I can do a get nodes -o wide to kind of see additional information. We see the IP address of each node, what OS they're running. To verify here, I can do cat etc OS releases. So you can see here, we are running Rocky 9.2, each of those nodes, the version, the containerd runtime. This is where you see in similar distributions, the Docker runtime, but we prefer the containerd runtime. But that's it. We have RKE2 up and running. We have a 3-node cluster. Now there's a lot more advanced things you can do with high availability, load balancers, a lot of these advanced features, but again, we're doing an easy and effortless installation. So we're going to move on to installing the Rancher multi-cluster manager. That's a mouthful. You can see here, just like the other code blocks, we're running this on the first node. And again, that's the reason why we closed our second node, so we don't accidentally paste these commands into the wrong node. You can see for this set of commands, we are installing Helm, which is a package manager for Kubernetes. And Helm consists of Helm charts and a few different things that make up ways to define Kubernetes manifests in a more reproducible way. So instead of running these things individually and by hand, we use Helm. So that first set of commands, we installed the Helm binary in Helm, and now we're going to add 2 repositories which host cert manager and Rancher, the Rancher multi-cluster manager. So you can see we run that set of commands, we have those repositories, and then we're able to actually use Helm to install these 2 things. Now, Cert Manager is a certificate management tool. It is one of the many ways you can manage certificates in Rancher and inside of Kubernetes. It's easy, it works, it's simple, so we're going to be using that for installation. Now, a lot of our customers do use private certificates, and you're able to do that very easily inside of Rancher. So we pasted that second command, or that second code block in, and that is installing Cert Manager. And with the rest of these commands, you can see we're going to be running one. We have a quick sleep statement to allow all the resources to come up. And then we also do a kubectl get pods with the namespace of each application, so we're able to see exactly which parts of the application have come up and running. So if I head back over here, you should see we've successfully deployed Cert Manager. We're waiting for those pods to come online, the resources to create, and you can see all 3 resources are up and running. So that means we're able to go back to the documentation here and install a Rancher Manager. Now, as we install a Rancher Manager, I'll run through exactly what this command does. We don't have many options. What we're doing here is we are specifying the namespace to install it in. We're specifying what password to use, because initially when the Rancher Manager comes online, you have to enter an initial password before you change it or enable authentication. And then we're also setting a domain name. For ease of use, you guys are able to use these exact same domain names just with your IP addresses. slip.io gives you the ability to direct any IP address as a host name, as DNS, because you have a lot of dependencies on DNS. So we look back here, you can see again we have also a sleep statement and then a get pods, but instead of the Cert Manager namespace, we have the cattle system namespace. Once that's up and running, we can see we're still creating the containers. I can go back up and do a watch command as well to see those containers are still coming online, but it shouldn't take too long. While we wait for those resources to create, we are going to scroll through here. You can kind of see the process that we're going to be going through. That initial password that we defined in the installation command, we enter that there. We accept the EULA, and then we move forward and we have access to the Rancher Manager. Well, we should be coming online here. We are now in the running status. We're waiting for those pods to become ready. It usually takes about 2 minutes. It depends on connectivity and a few different factors, but you can see we're coming online now. So if I exit out of this watch command and just run kubectl get pods, we can see that as well. So I'm going to head over to that domain that we defined up here. Again, this is going to be the exact same thing for you. All you need to do is just substitute that IP address. Again, we're using self-signed certificates with Cert Manager, so we do have to accept those as we move through these products. We are going to head back to the docs to grab that password that we set. You can see right here, Rancher secure password. Once we log in with that, we're able to not send our statistics back to Rancher and accept the EULA. Once we accept that EULA, you can see we are now greeted with the global Rancher Manager dashboard. Now, I'm not going to get into specifics about each product and how to use them. Those are going to be videos down the line. But for today, you can see we now have the Rancher Manager up and running, and we have access to our local cluster. And to verify that, you can see these are the same 3 nodes that we've been working with this entire time. Now that we see the Rancher Multi-Cluster Manager is fully up and running, we're going to move on to the storage aspect. So we head back to this repository. You can see we had some overview screenshots, and then we're getting right into Longhorn. So this is going to be the same process for all of these Kubernetes applications. That is going to be adding those Helm repositories by pasting in those same commands that we saw for the Rancher Manager. And then we're also going to be doing the Helm installation commands, waiting for those resources to come up, and then seeing if they fully came up as well. So breaking out the Longhorn command, as we did with the Rancher Manager command, you can see we're enabling ingress. We're setting a domain name. So in the Rancher Manager, there's 2 ways, or there's a few ways to access applications, but the 2 main ways we see customers access applications is going to be through ingress, which is going to be going to rancher.domainname.com or longhorn.domainname.com. And then you can also use the Rancher Manager and its proxy, which utilizes RBAC and authentication to access your applications that way as well. So Longhorn does take a little bit longer to come online. You can see that we still have a few containers and pods being created. So if we run this command again, you can see quite a big jump of resources. But again, this takes about a minute. It's not very long. Now if we go back, you can see the ingress that we enabled is going to be the same thing as the Rancher Manager, and that's going to be using slip.io. And if we paste that in, we should be able to access and see these resources as they're coming online. Now, it won't be fully online, and we can check that by running that same command again, the kubectl get pods, and it looks like it's about fully created. But exploring the Rancher or the Longhorn interface, you can see we have a nice dashboard, gives you an overview of your storage information on the cluster. And to trust but verify one more time, you can see if we click on our nodes tab, it's those same 3 nodes. Again, I don't want to get too deep into Longhorn, but it's a really powerful tool. It's great for stateful storage, persistent storage, cluster-wide persistent storage. There's many ways you can approach storage in Kubernetes, and Longhorn is a great choice for using that available storage that is going to be on each of the nodes inside of your cluster. Keep scrolling through again. Rancher NeuVector, our security tool. It's an amazing tool. There's a lot of cool things you can do with it, and we're going to be installing it just like Rancher and just like with Longhorn using Helm. So we're going to start by copying and pasting that Helm install command. It's going to add the Helm repository, and then we are going to go down here and use Helm install to install the product. Now you'll see here that there's quite a few installation options that you see, and I'll walk through those quickly. But due to the fact that we're using Rancher and RKE2 with NeuVector, we're going to enable the correct location of the runtime path for container D, and that's using the K3s runtime path. RKE2 and K3s share the same path for it. We're going to enable ingress. We're also going to change the service type to cluster IP. In Kubernetes, there's a few different ways to define how services are accessed. I prefer to use the cluster IP for NeuVector, so that's why we're doing that here. And then we're also enabling storage. We installed a storage product, Longhorn, right? So we're going to enable NeuVector to use persistent storage with Longhorn. And then we're also going to be setting the ingress URL and enabling access to the Rancher Manager. And that's what these last 3 commands do. So very, very simple commands, nothing out of the box crazy, not any configuration options that you typically wouldn't see, but I still want to make sure you guys understand what is happening here. So I head back to the terminal. You can see that our containers are coming online. Looks like most of the pods have been created. So we should be able to head over to the ingress URL. And that's going to be the same thing using slip.io. Accept the insert secure certificates. And then the default login for NeuVector is always going to be admin. And that's also going to be shown in that README. So we're going to enter admin, agree to the EULA, and you can see now we have access to NeuVector. So NeuVector does a lot of things. It can do runtime security, it can do build time security, registry security. There's a whole list of things. I don't want to get too deep in any of the products. I will give you one tip. Once you install NeuVector, make sure you head over to this right-hand side, click on the 4th dot, and enable auto scanning. So NeuVector will start scanning your resources, and you can kind of see what NeuVector is able to do. And that's it. In about 15 minutes, we have the entire core Rancher stack up and running. We have a 3-node Kubernetes cluster. We have management with the Rancher multi-cluster manager. We have storage with Longhorn, and then we have security with NeuVector. It's pretty powerful, I think. A lot of our competitors aren't able to install this easily and this quickly and this effortlessly. So I'm really happy to be able to show you guys how easy it is to get started with Rancher. And all of this that we've done here today is open source, available to you today. All you need is your 3 virtual machines. Again, my name is Zach Brady. I'm a field engineer here at Rancher Government Solutions, and I hope you guys have a wonderful time exploring our products. Thank you for listening. Thank you for watching. Please share. Please like.